Hello, and welcome to Investigative Math. Today, we will be learning how to find the greatest common factor of two numbers. So let's get to it. For our first problem, we are asked to find the GCF of 24 and 60. Now, many of you will be able to just look at this and tell me what the greatest common factor is. Spoiler alert, this is going to be 12. And that's often how I do it on the test. This is fine. But I'm going to show you a way that you can find the greatest common factor if it's not immediately obvious. So we're going to use a method that everyone calls, the Euclidean algorithm. Euclidean algorithm. All right? And basically, what the Euclidean algorithm says is that the GCF of A comma B, for this problem, A is 24 and B is 60, is the same thing as the GCF of A in the difference between B and A. So, let's try to use this on our problem. So we're trying to solve for the GCF of 24 and 60, which, according to the Euclidean algorithm, should be the same thing as the GCF between 24 and 60 minus 24, which is 36. Now, it's a little bit easier to see what the greatest common factor of 24 and 36 is than for 24 and 60. But if you still don't see it, or you just want to be 100% sure that your answer is right, we can keep going. So, I'm going to move the GCF of 24 and 36 over here and use the algorithm again. So, the GCF of 24 and 36 will also be the same thing as the GCF of 24 and 36 minus 24, which is 12. Okay, and now we have to find out the GCF of 24 and 12. At this point, once you get to this step, it should be very obvious what the greatest common factor is. But for the sake of learning this, I'm going to take it one step further and show you how this will always end. We want to find the GCF of 24 and 12. So, actually, my bad, of 12 and 24. Because, right, we set it up so that the left term is less than the right term. A is less than B. Okay, so the GCF between 12 and 24, according to the Euclidean algorithm, is the same thing as the GCF between 12 and 24 minus 12, which is 12. And at this point, it's like right in front of your face. The GCF between 12 and 12 is obviously going to be 12. So if at any point along this process, you can tell me what the answer is. For example, I didn't use this at all because I've been doing number sense for a while, and the GCF of 24 and 60 being 12, it's just instant. It's just instantaneous if you do it for long enough. But if you don't see it right away, this is a method you can use to find it easier, to find it without having to just look at it and know. So there are a lot of videos about this Euclidean algorithm. You should check some of them out. A lot of them are pretty cool, actually. But there's another way that they can ask for the GCF, and that is our next example. Sometimes they will ask for the greatest number that divides into two numbers with a remainder of 0. So that brings us to our second question. What is the greatest number that divides into 42 and 56 with a remainder of 0? Maybe you can tell, but this is exactly the same thing as asking for the GCF of 42 and 56. Because the greatest number that divides into these two numbers is the same thing as the greatest common factor. So we have to find the GCF of 42 and 56. Again, if you see what the answer is right away, you can just write that. But if it's not immediately obvious, remember, we can use the Euclidean algorithm. So we want to find the GCF of 42 and 56, which according to the Euclidean algorithm will be equivalent to the GCF of 42 and 56 minus 42, or 14. Once you get to this point, it's a little bit clearer than what we have back here. But let's take it one more step. We want to find the GCF between 42 and 14. Oh, I did it again. Between 14 and 42. Those are exactly the same thing. I just have it in this format so that the Euclidean algorithm works properly. It's not really that important. You don't have to worry about it. So GCF of 14 and 42 will be the same thing as the GCF of 14 and 42 minus 14, or 28. Okay, I realized earlier I said the order doesn't really matter. As long as you take, GCF of A comma B. As long as this is equal to the GCF of the lower number and the positive difference, then you're still good. Just make sure just make sure B minus A is positive, basically is what I'm trying to say. As long as B minus A is positive, you're good. So when I said it doesn't matter, that was kind of a lie. But yeah, just try to keep these numbers positive and you'll be good. Okay, so back to our problem. So now we know that the GCF of 42 and 56 is the same thing as the GCF of 14 and 28. So at this point, most people will be able to see what the GCF is, but for the sake of learning, again, I'm just going to take it one step further. So the GCF of 14 and 28 is going to be equal to the GCF of 14 and 28 minus 14, which is 14. And once you're at this point, the answer is basically given to you. So the GCF between 14 and 14 is obviously going to be 14. And if you're curious, yes, this does always happen. If you do the Euclidean algorithm over and over again, you will always end up with the GCF of two of the same number. So the greatest number that divides into 42 and 56 with a remainder of 0, that would be the GCF, or the greatest common factor, of 42 and 56, which is the same thing as 14. Now, one little side note, sometimes on Number Sense and just throughout your math career, instead of asking for the GCF, they will ask for the GCD, which stands for greatest common divisor. This and GCF are exactly the same thing. It should be treated as the same thing. So, that does it for finding the greatest common factor of two numbers. Now to give you an idea of how to do this kind of question, I have provided a problem set in the description of this video for you to try a couple for yourself. If you need me to clarify anything for you, leave a comment and I'll go back to you as soon as I can. If you enjoyed this video and found it informative, leave a like. And if you really loved it, make sure to subscribe. I'll see you later.